All right, let's get right into it. We're talking about something pretty amazing today. Artificial intelligence stepping into the operating room, not to replace surgeons, but to act as a sort of co-pilot during one of the most common surgeries in the world. This is all about making a routine procedure safer, smarter, and way more reliable.
But to really get a feel for this, let's start with a question. What if an AI could prevent a surgeon's absolute worst nightmare? I mean, imagine an intelligence system that's always there, looking over their shoulder, helping them avoid that one critical mistake that could change a patient's life forever. That's the high-stakes world we're jumping into.
And this isn't some niche problem affecting a handful of people. That number you see, 1.2 million, that's how many gallbladder removal surgeries happen around the globe, every single year. It's a fundamental, everyday procedure, which makes getting it right absolutely crucial.
So let's peel back the curtain on this hidden challenge. Because even though this surgery is considered routine, there's a risk lurking inside that you might not expect.
You know, the biggest danger here isn't a surgeon's hand slipping or a lack of training. It's actually a simple but devastating error of perception. A surgeon in the middle of the procedure might just misidentify one critical structure for another, mistaking, say, the common bile duct for the cystic duct. And that one little mistake can lead to some really severe, life-altering complications. So you're probably thinking, okay, AI seems like the perfect solution, right? Just train a computer to recognize all the anatomy. Well, it's not quite that easy. Turns out, AI has its own massive hurdle to clear, especially when you bring it into the medical world. And that problem is called data annotation. See, to teach an AI what a gallbladder looks like, you need an expert, an actual surgeon, to sit down and manually trace the organ, pixel by tedious pixel, over thousands of video frames. And get this, to create just one high-quality labeled image can take that expert surgeon hours. It's this incredible bottleneck of time and money. And this really lays out the core dilemma perfectly. On one hand, you have this tiny, super precious pool of labeled data. It's fantastic, but it's expensive and incredibly rare. On the other hand, you have this massive, untapped ocean of unlabeled data, just countless hours of surgical videos sitting on hard drives. The million-dollar question is, how in the world do you get an AI to learn from all that unlabeled footage without a surgeon holding its hand every step of the way? Well, this is where the researchers behind this work got really, really clever. Their solution basically comes in two parts. First, they decided to build a better, smarter, more efficient AI model right from scratch, one that was tailor-made for this job. They made two key upgrades. Think of the first one, the DWR module, as giving the AI a set of bifocals. It helps the AI see both the tiny, critical details up close and the overall surgical field at the same time, which is essential if you want it to work in real time. The second upgrade, this BIFPN module, it's like a smart information pipeline. It lets the AI blend those small details with the big picture context, giving it a much deeper, more complete understanding of what it's looking at. But, you know, building a better model was only half the battle. The real genius move, the genuine breakthrough, was creating a framework that could teach this new AI how to learn all by itself, using that huge ocean of unlabeled video we were talking about. So how does this actually work? Well, think of the AI as a student. First, in step one, you give it a small, curated textbook with all the answers perfectly labeled by the teacher. Then, in step two, you unleash this student on a giant library of unlabeled books and tell it to try labeling them on its own. For step three, you go through its work and only keep the answers it's, say, 99% sure about. We call those pseudo-labels. And finally, this is the magic part. You have the student study its original textbook plus all of its own high-confidence notes. It's this powerful feedback loop where the AI literally teaches itself to get smarter. Okay, so that's the theory. A smarter AI model that teaches itself. It sounds fantastic on paper, but did it actually work in practice? It was time to put it to the test. And the results were, frankly, stunning. Just look at this. On a key accuracy metric, which basically just measures how well the AI finds the right objects, the old standard model scored a 55.6%. Just by improving the AI's architecture, their new LC YOLO model jumped all the way up to 69.6%. That is a massive improvement right out of the gate. But that was just the warm-up act. The main event, the real game changer, was when they unleashed that self-learning framework we just talked about. Because when they combined their custom model with that self-teaching method, letting it learn from thousands of unlabeled images, the final accuracy score shot up to 70%. This just proves the incredible power that was hiding in all that untapped data.
So let's put this into perspective, because this is the really crucial part. They didn't just nudge the needle forward, they set a totally new standard. Their full system, LC YOLO Match, took that key accuracy score from 55.6% all the way to 70%. And on an even tougher metric, one that demands almost perfect precision, the score leaped from 28.4% to 40.8%. I mean, in the world of AI research, a jump like that isn't just an improvement, it's a breakthrough. It sets a new state of the art.
All right, so we've seen the impressive numbers, but let's zoom out. What does all this techie stuff actually mean for the real world, for the doctors in the OR, and even more importantly, for the patients on the table?
Well, the clinical impact could be huge. We're talking about real-time guidance that highlights critical anatomy for the surgeon, directly cutting down the risk of those dangerous misidentification errors. It could help new surgeons get up to speed so much faster. And for even the most experienced surgeons, it's like having a tireless, vigilant second set of eyes during the trickiest parts of an operation. And look, I want to leave you with this powerful thought directly from the researchers themselves. They said that this level of consistency can directly help surgeons by, and I'm quoting here, reducing the possibility of misidentifying the connection between the cystic duct and the common bile duct. In other words, preventing the exact error that causes the worst injuries. It's not about replacing surgeons, it's about empowering them. What this research really shows us is that an AI co-pilot in the operating room is quickly moving from the realm of science fiction into clinical reality. So the question isn't if anymore, it's when. Will your next surgeon have an AI co-pilot? Based on this, it might just be sooner than any of us think.